Hey everyone, today we're going to be taking a look at two more of the toolkits available in Monsoon's new Hardline series of pro bending kits. Because these two kits actually work very well together, we're going to be looking at both of the kits at the same time. And because we're going to be covering quite a bit of material, I'm actually going to break this particular how-to video up into 3 parts. So this is the first part of a 3-part series. The two kits we're going to be looking at, I'll start with the bending mandrels. These are machined from aluminum, polished, and then anodized. They have the degree marks in 1 degree increments laser etched onto them. There are mounting holes that allow you to use the provided screws to mount them flat to your workboard, or with the included brackets you can mount them upright, like I've done here on the other sides. What this allows you to do basically, you can mount brackets flat and upright so that you can either fixture or bend in 2 different directions or 2 different axes. I'll get into this more later. Included are all the screws you're going to need, the Allen wrench, everything that's involved with the mandrel kits themselves. The second kit we're going to look at today is the measuring kit. This should actually be called the measuring, or the loop planning and measuring kit, because it performs both functions very well. What's included in this are 3mm laser cut acrylic rules. These are silk screened in 1mm increments, and then every 10mm is denoted. You get a 300mm, a 200mm, and then 4 100mm rules. You get brackets in 90 degree and 45 degrees so that you can plan and measure your loops in actually in all 3 axes at the same time. Included also are butterfly nuts and butterfly bolts. You get a little bag of those. And a laser cut acrylic right angle to do just that, make sure everything's at a right angle. Up next, I'm going to show you how to do a real basic loop. We're just going to do a simple 2-axis with a single 90, and I'm going to go over to a little mock case that I've set up and get the first set of dimensions. A couple things I want to go over real quick before we start getting dimensions. The way these are designed, they have the 1mm marks right up to the very end. If you look at a traditional ruler, there's a little bit of dead space that's about 1/8 of an inch or 2 or 3 millimeters. So you can't ever get right up to the edge of something to measure. So these actually go right off the end of the scale. In a minute, when you see me actually measuring inside our little mock case, you're going to notice, or you should notice, or I should tell you, I guess, that I've put the 0 side towards the fitting. So if I've got 2 rules set up like this, going from a fitting here to a fitting here, I'm going to put the 0 side on this end and the 0 side on that end. Alright, we'll be right back after we've got our dimensions. Alright, I've got a little, call it mock computer set up here to kind of simulate the problems you encounter when you're trying to get dimensions inside your PC. No matter how careful you are when you design things, if you're using SolidWorks or SketchUp or any of the 3D modeling type programs, the dimensions would never be accurate in the software. You're always going to want to be able to get dimensions physically right within your build, if at all possible. I've got this set up as a GPU block right here, and we're going to be running from this fitting. I've gone ahead and mounted the base of the fitting in place. These are for our premium line of Hardline fittings that use a base. This is the base that uses hard lock, but if you're using another fitting, just put the base itself in. I'm going to be running from this port on the GPU block to this port on the chipset block, and then in later videos I'll be running from this port on the chipset to this port on the CPU, and then to show bends in all 3 axes. And the third part of this video, we're going to be running from this port on the GPU to this port on the CPU. But for right now, I've got this little set up. I'm just going to try and position it right into the center of each fitting. And need to make a little adjustment. I'm going to loosen a little bit, slide it over some, tighten it back down. Went a little too far. Alright, center of this fitting. to the center of that fitting. I actually like the way that looks. Looks like I'm right on the money. So just to confirm that I'm at 90 degrees, because you don't want to over tighten these because you can break these. They're only acrylic. We've tried to keep the price down low enough that people that are just doing one build, I don't know if you can see there, but I'm checking to make sure I'm at 90, which I am. I've tried to keep the price on these down low enough that they make sense to someone who's only doing one or two computers, and still try and be durable enough for somebody that does 2 or 3 or 4 or 5 a year. So when I set this up, I mentioned it earlier, I set up my 0. The rules are actually denoted right up to the very edge. There's no little dead space that doesn't have dimensions. So you always want to put the 0 side and the 0 side to your fitting. So I've got the 0 side to this fitting and the 0 side to that fitting. I've double checked that I'm at 90 degrees just to make sure, because we want nice precise lines of tube in our build. And I'm going from the center of that fitting to the center of this fitting, and I like that. And then I can just look at here and see that it's 144 millimeters and 106 millimeters. Next up, we're going to be on the building board. Alright, we've got our dimensions and we're back at our building board. Actually, before I show you how to transfer those, I might want to talk about the building board for a second. I actually laid down a old towel first on the top of the table to prevent the building board itself from moving around and scratching the table, and also holds it in place. The towel's not in any danger, so you don't have to use an old towel. Any towel will do. The building board itself is a scrap piece of 1/2-inch MDF like this that I had laying around. I actually used it to build this workbench that I'm on. It can be any type of 1/2-inch plywood. The size of this particular piece you see me working on here is about 17 inches by 24 or so. Ideally, maybe you might want a 24 by 24 board that you can pick up at any of your box type home improvement stores for under 10 bucks. They're very useful to have around even when you're not doing this, because I take mine and I lay them out when I'm spray painting things, or just lots of different purposes around the shop. I then put a piece of paper over the top of it just because I'm going to be using a pencil and I want to be able to see the marks. Pretty basic stuff for your building board. I'm also using a cordless screwdriver, you'll see later, but you can use a regular screwdriver if you don't have one. You just give it a couple of, put it in the screw, give it a couple of taps, and then screw the screw in by hand. These just make it a little faster. Alright, we used our rules to get our dimensions. I don't know if it'll show up on the camera, but from our 0 side where the fittings were, my dimension this way is 144, and my dimension this way is 106. So just so I don't forget that, I'm going to make myself a little note here. 144 and 106. This kind of helps us visualize what we're doing. And then down here, my building surface, I don't know if I'm centered well enough here, but we'll try and see. I'm going to use the right angle that's included with the kit. Ordinarily I would just use my ruler here to extend these lines out a little bit. Alright, I'm going to transfer my dimensions over, which is, I guess I can go ahead and take this apart real quick because I do need the longer ruler now. Alright. 144. That's 140, 1, 2, 3, 4. And 106. All right. Let me just take my ruler, make a stop point. That actually gives me my dimensions now. One of the problems you're going to find when you're measuring inside your case, or you're just trying to eyeball it, which I would obviously never recommend. If you're in there trying to eyeball it, the tube is round, there's lots of different light sources, it's just ripe for optical illusions. What's going to happen, and I speak from experience, is you'll put the bend, if you're eyeballing it or sort of freehanding it or whatever you want to call it, you'll end up with a bend here, you'll go put it back in the case and it turns out it's about 3/4 or an inch too far this direction. So you go over, you'll cut that off at 1 inch off, and then you come back, and now you've gone too far. It's a 1/4 inch too far the other direction. So you heat the tube back up and bend it, and pretty soon your tube's kind of wobbly, and it's just not real precise. It doesn't, have that real crisp military precision we're looking for. Excuse me. The next thing you'll try is some type of coat hanger, and again, I speak from experience. I tried to bend the coat hangers and do all that, and the problem is the bend in the coat hanger itself, and anytime you're dimensioning something, if you've got a fitting here and a fitting here, and you're building a loop, do I measure from the left side of this fitting to the right side of that fitting, or from the inside to the inside? When I measure, they're never at the same height, so do I measure from the fitting to the bottom of the tube, or to the top of the tube? Am I using the inside radius or the outside radius? Do I need to use a K factor? Do I measure from the end of the bend down? It's just a bunch of crap that you don't want to mess with. As I mentioned earlier, the mandrels themselves have centerline capabilities, and what that does is I don't know if it'll show up in the camera, but this line right here is the dead center of the tube, so you don't have to guess. So anytime you're measuring anything in the machine to get a dimension, you just measure from the center of one fitting, no matter where the other fitting is in the case. After you've done your loop planning, you measure to the center of the other fitting. And that gives us these dimensions right here. And then if we just take our mandrel, I'm just using this ruler because I can't see the other side of it. I don't want to lean over in front of the camera, but so it's telling me where the end is, which is right there. And then if I make my loop, you don't have to do that, but that gives you an idea of where the actual loop itself is. You can kind of already see what's coming here. The next step is we're going to take our 90-degree mandrel, because we're bending a 90-degree, and again I'm going to just put my ruler on here because I can't see the other side without leaning over and blocking the camera. I'm just going to line it up on this line. Now right there, that's the center line of it. Take my cordless screwdriver. I've got the clutch set at about 10 so you don't strip out the board itself. Now what we've done, we've got the center line to our center line dimension on both sides, and we've got our perfect length. One quick note on perfect length: if you're using the dimensions I took are with our Monsoon premium fittings, which have a flat base, so you don't have any extra calculations to do. But if you're using a push-in style fitting, one thing you will want to do, I've got a piece of tape here off of another project. You're going to want to take a piece of tube, push it, I guess I can just take the compression ring off. And because the tube itself actually slides down inside the fitting in the push-in style, you're going to want to push a piece of tube into it as far as it'll go, and take your tape, I don't know if you can see this or not, take your tape and put it right up against the edge of the fitting and get that dimension. And in this case that dimension is 8 millimeters. You'll only have to do that one time for whatever fitting you're using, and then you just write down somewhere 8 millimeters so that you remember it, that your add-in dimension is 8 millimeters. Then what I'm going to do anytime I'm actually getting my dimensions, I know I just need to add 8 millimeters to the end of this, and 8 millimeters to the end of this. So that's my actual length, because I want that little extra bit that's pushing down inside the tube. And again, you'll only have to make that dimension measurement the very first time you do it, because that's assuming all your fittings are the same. I'm going to go bend a piece of tube real quick, and when I come back I'll show you how it fits in there, and the next stage of this process, which will be marking off the tube length for cutting. And again, I'm going to borrow a piece of tape off of this other. What we're going to essentially do, the other nice thing is when I'm going through my scrap bin, because I've got my marks laid out now, I'm able to dig through my scrap bin and find pieces of tube, lay it in there, and then carefully do a little sort of test bend. This isn't going to be super precise, but it'll give you enough, so I know that this piece of tube is long enough. And that kind of brings up the next item here, is if you were, after you have bent your tube, I'll end up showing you this again, but you've got a little bit left over on each end and you're going to make your cut, just put a piece of tape on there. Say this tube is already bent, and I've got the line right there where I can put my mark so I know exactly where I need to cut to have the exact length. Alright, I'll show you that again after I'm back with a piece of bent tube. Alright, because we use the Mandrels fixturing ability on our building board, the bend went nice and smooth. If you're not familiar with how to heat and bend the tube, I suggest you watch our bending video. It covers the heat gun. I don't know if it shows up in the video, but one of the things I did was I ran the silicone insert rod to about 1/4 inch past the outfeed arm of the mandrel, and that gave me an idea of where to actually heat, because when you are sitting there holding your tube, you've got your heat gun, it gets a little confusing about where do I actually need to heat this thing. Again, we cover the actual tube bending in the heat gun kit video. We're almost there. In part 2 of this series on the measuring kit and the mandrels, because this video is designed to actually show the ability of the measuring kit to plan loops and use centerline capabilities of the mandrels, for the second part of this video series I'm going to add the chipset block to CPU block, which is similar to this, but it adds another leg in the Z-axis, and that'll show you how to start using the fixtures in combinations, which will really start to highlight the abilities they have to work as fixtures and the centerline system. I think we're actually there. That looks like it came out real nice. I'm going to go ahead and pull the silicone rod out, wipe some of my fingerprints off of it. I don't know if the camera will pick it up, but if you look, the legs are perfectly straight. There's no wobble to them. It's a nice, beautiful 90-degree. It's just exactly what you'd want in a bend. And if you can see the lines, we're dead on our center lines. Also, I went a little bit past, because I was using pieces of scrap tube I had left, I went a little bit past our cut mark on either end. After you've had a few bends of practice and you've got a nice clean edge on the end of the tube, when you start your bend, when you get back over here, you can real quickly set the tube in place, line it up onto your mark, and then make your bend. And you'll only have one cut to do on the other end. Cutting's relatively simple. I don't mess with it. What we're going to do next is just put a piece of tape over our mark. Give it a few wraps. Fold the end over. Put it back in our jig. Take our pencil, which seems to have disappeared. Oh, you gotta be kidding me. Oops, under here. Sorry about that, it's trying to escape. I've actually got a mark right there from a previous time I used this tape. I don't want to confuse myself. All you're going to do is just transfer that mark onto the tape. I'm going to repeat that over here. It's another benefit of using the fixturing portion of this, because it lets you mark down the length of each leg so that you can get a real precise cut. And I'm going to do the same thing again. Just mark my marks. If you haven't watched our video on cutting, the next step would be to just insert that into your mandrel, or excuse me, into the miter box, line the mark up, and make the cut. I highly suggest you watch that one, obviously, also, because all the tools are really designed to work together as a system. That wraps up part 1 of this. Again, in part 2, we're going to be doing the leg from the chipset block to the CPU, which is a similar shape, except it adds another bend in the Z-axis, and there's a differential in height. What we're going to do when we do that is we'll be adding one of these in here, and you'll see how they work together. That'll cover you guys for this one. Stay tuned for part 2.